Okay, so this is section 5.2, and section 5.2 is just verifying trig identities, which is basically what we did in section 5.1. So I made some guidelines for verifying trig identities. So number 1 says work with one side of the equation at a time, and it's often better to work with the more complicated side first. Number 2, look for opportunities to factor an expression or add your fractions, square a binomial, or create a monomial denominator, which means you might have to multiply the top and the bottom by something. Look for your fundamental identities, especially your Pythagorean trig identities. And then try converting all terms to sines and cosines. So it just depends, and each problem is going to look a little different. So let's do example 1. Verify the identity secant squared theta minus 1 over secant squared theta equals sine squared theta. So here's what I did. I automatically noticed that secant squared theta minus 1 is a Pythagorean identity. That's equal to tangent squared theta. So I changed the top to tangent squared theta. Okay. Now I'm going to write this in terms of sines and cosines. Tangent is sine over cosine. Now I'm going to say divided by secant, but secant is 1 over cosine. So now I have fractions. To multiply fractions, I multiply by the reciprocal. So I have sine squared theta over cosine squared theta times the reciprocal. My cosines cancel, and I have sine squared theta. Now, in your book, they worked this problem a completely different way. So there's lots of ways that you can work most of these problems. Okay, so let's look at example 2. Verify the identity. Okay, and so I want the left-hand side to look like the right-hand side. So the first thing I see is I see two fractions that need to be added together. So I'm going to find a common denominator. My common denominator will be 1 minus sine theta and 1 plus sine theta. So this first fraction, its denominator is only 1 minus sine theta. So I need to multiply this by 1 plus sine theta. And I'm actually multiplying the top and the bottom by that. So that top is going to change to 1 plus sine theta. This denominator is missing my 1 minus sine theta. So that's what I'm multiplying the top and the bottom by. So now I have 1 minus sine theta. Remember, we're trying to make this look like 2 secant squared theta. So if you notice, my sines actually cancel out. So now I have 2 over. Now, I could go ahead and write this out as a factor like that, but I'm wanting secant squared theta, so I'm going to go ahead and FOIL this out. When I FOIL this out, my middle terms cancel, and I get this, because this is the difference of squares, 1 minus sine squared theta. And if you'll look, 1 minus sine squared theta is a Pythagorean identity. 1 minus sine squared theta is cosine squared theta. And we could think this is over 1. So what is 1 over cosine? 1 over cosine is secant, and I have my 2 there, so this is 2 secant squared theta. Okay, example 3. Verify the identity. Okay, so on this one, there's lots of ways you can do this one. I first noticed that these are probably Pythagorean identities. So looking on your sheet, tangent squared theta plus 1 is the same thing as secant squared theta. Now, cosine squared theta minus 1 is really close to sine squared theta, but my signs are wrong. So if I factor out a negative, it's equal to sine squared theta, and so this is actually equal to negative sine squared theta. So now I'm going to write all of this in terms of sines and cosines. Secant is 1 over cosine squared theta times a negative sine squared theta. That gives me negative sine squared theta over cosine squared theta, which gives me negative tangent squared theta, which is what I wanted. Example 4, verify the identity. Tangent x plus cotangent x, and we want it to equal secant x times cosecant x. So I'm going to change this side. I'm going to start off just changing it in terms of sines and cosines. So tangent is sine over cosine. Cotangent is cosine over sine. So now I have two fractions that need to be added together. So I need a common denominator, which is cosine x times sine x. So my first fraction is missing a sine x, so that's why I need to multiply the top and the bottom by. So sine x times sine x is sine squared x. This fraction, its denominator is missing a sine x, so I'm sorry, it's missing a cosine x, so that's what I'm going to multiply the top and the bottom by. So cosine times cosine is cosine squared x. This becomes a Pythagorean identity. Sine squared plus cosine squared is 1. And then what is 1 over cosine? 1 over cosine is secant, and 1 over sine is cosecant, which is what we wanted. Example 5, verify the identity. Okay, this one, lots of different ways we could do this one. My hint to you is we're going to work with the right-hand side. Okay, so you don't always have to make the left look like the right. This one, I'm going to change my right-hand side to make it look like the left. And there's really nothing I can do with this. So this is the one where in my notes it says look for opportunities to factor or create a monomial denominator. That's what I'm going to do. I'm going to multiply this fraction by this, 1 plus sine x over 1 plus sine x, because that's actually 1, and I can multiply anything I want as long as I don't change the value. All right, so just looking at this right-hand side, okay, so on top I have cosine x times 1 plus sine x. And on bottom, if I FOIL this out, this is the difference of squares. My middle terms will cancel, and I get 1 minus sine squared x. Now, 1 minus sine squared x is a Pythagorean identity. So I'm going to rewrite the top. 1 plus sine x. 1 minus sine squared x is cosine squared x. So do you see that I can cancel one of these cosine x's? So this is now gone. I have 1 plus sine x on top, and I only have 1 cosine x on bottom now. So now look at what I actually have. I actually have 1 over cosine x plus sine x over cosine x. Well, what's 1 over cosine? 1 over cosine is secant, and sine over cosine is tangent, which is what I'm wanting. Okay, last one. Example 6. This is an example of, this problem is going to be easier to change each side and make each side equal each other. I know that sounds weird. So I'm going to work with both sides and try to make them equal. Okay, so for example, I'm going to work, let's see here. I'm going to do the left-hand side first. Okay, so I have cotangent squared x over 1 plus cosecant x. So the first thing I need to do is, can I rewrite cotangent squared x? I have cosecant down here, maybe rewrite it using cosecants? Okay, so how can I rewrite cotangent squared x? Well, using a Pythagorean identity, cotangent squared x is cosecant squared x minus 1 over 1 plus cosecant x. Now, do you see that this is the difference of squares? So I can factor this as cosecant x minus 1, cosecant x plus 1, all over 1 plus cosecant x. So now do you see what cancels? This will cancel, and I end up with, I don't know what's wrong with my pen, cosecant x minus 1. Okay, so let's see if we can make this side look like cosecant x minus 1. Well, let me write it down. 1 minus sine x over sine x. Well, this one's pretty easy to make it look like that. Look, I can rewrite this as 1 over sine x minus sine x over sine x. Well, what's 1 over sine x? That's cosecant x. What's sine x over sine x? That's 1. So there's my work. Your work verifies that it is an identity. Okay? All right, I forgot to put the assignment on your sheet. So your assignment for this problem is this right here. Section 5.2, page 353. You're going to do 1 through 10, 13 through 16, and then 40 through 46. So let me see if I can copy this over there. Here, let me do this real quick. Copy. Oh, shoot. Okay, so on your paper, right? So that's your assignment, page 353, 1 through 10, 13 through 16, and then 40 through 46. We'll probably look at a lot of these Monday in class, but I want you to try and do as many as you can.